Mass hall diagrams, or MHD, are used to compare the economics of the various methods of earthwork distribution on road or railway construction schemes. With the combined use of the MHD plotted directly below the longitudinal section of the survey center line, one can find the distances of which cut and fill will balance, quantities of materials to be moved and the direction of movement, areas where earth may have to be borrowed or wasted and the amounts involved, and the best policy to adopt to obtain the most economic use of plan. Furthermore, MHD is a diagrammatic representation of earthwork volumes along a linear profile. It consists of horizontal stationing plotted along the x-axis. Net earthwork values are plotted along the y-axis. An earthwork profile is a plot of the net earthwork along a roadway or airstrip. Net cut values are plotted above the x-axis, while net fill values are plotted below the x-axis. This presents a picture of the earthwork requirements. Also, upward sloping curves rising left to right indicate a cut, while downward sloping falling left to right curves occur in a fill section. Peaks indicate a change from cut to fill, while valleys occur when the earthwork changes from fill to cut. The accumulated volume of earthwork at the horizontal axis is 0. When a horizontal line intersects two or more points along the curve, the accumulated volumes at those points are equal. A negative value at the end of the curve indicates that borrow is required to complete the fill, while a positive value at the end of the curve indicates that the waste operation will be the net result. To construct the mass hall diagram manually, you need to compute the net earthwork values for each station, applying the appropriate shrink factor. Net cuts have a positive value, net fills have a negative value. The value at the first station or origin is 0. Plot the value of each succeeding station which equals the cumulative value to the point. As you can see, rising sections of the mass curve indicates areas where excavating exceeds fill, whereas falling sections indicate where fill exceeds excavation. Steep slopes reflect heavy cuts and fills, while flat slopes indicate areas for a small amount of earthwork. The difference in ordinates between any 2 points indicate net excess of excavation over embankment or vice versa. Any horizontal line drawn to intersect 2 points within the same curve indicates a balance of excavation or cut and embankment or fill quantities between the 2 points. Points of zero slope represent points where roadway goes from cut to fill or from fill to cut. The highest or the lowest points of the mass hall diagram represents the crossing points between the grade line, roadway level, and natural ground level. To construct and analyze the mass hall diagram manually, you need to identify the resulting balance sections, which are bounded by points that intersect the x-axis. Draw a horizontal line midway between the peak or valley and the x-axis. The scale length of that line is the average line of haul within that balance section. Determine earthwork volumes within each balance section, and determine whether there is an overall balance, waste, or if borrow is required. As you can see, this is the cumulative volume with shrinkage factor 10% with solution. This is the cumulative volume versus challenge. This is how you analyze the MHD. Line EF is free haul distance, CG free haul volume, CD haul volume, HI average haul distance to center line of CD, GD overhaul volume, and JK average overhaul distance to center line of GD. This is the calculation of MHD. Haul equals to haul volume times average haul distance over 100. Free haul equals to free haul volume times free haul distance over 100. And overhaul equals to overhaul volume average overhaul distance minus free haul distance over 100. As you can see, this is the cost of earthwork. Free haul prices in free haul distance equals to free haul volume times free haul distance times free haul prices. Overhaul prices in free haul distance equals to overhaul volume times a freehold distance times freehold prices. Overhaul prices and overhaul distance equals to overhaul volume times average overhaul distance minus freehold distance times overhaul prices. Borrower prices equals to borrower volume times borrower prices. And lastly, waste prices equals to waste volume times waste prices. Let's draw a mass hole diagram. Step 1. Draw a mass hole diagram using the scale given. Step 2. Determine the freehold distance and balance line. Step 3. Determine the freehold using the formula given. Step 4. Determine hole using the formula given. And step 5. Determine overhaul using the formula given. In short, this is the figure on how to calculate the freehold and overhaul. And lastly, the total cost of earthwork can be calculated easily. In conclusion, mass hole diagrams are important to compare the economics of the various methods of earthwork distribution on road or railway construction schemes.